Hi guys, so here's the understand video for lessons 4 and 5. There's just one video, but the practice is going to take a little bit longer, so that's why I gave you guys 2 days to do it. The practice is really awesome because it connects data to the coronavirus that's going on right now. The understand problem isn't about the coronavirus, but the word problem is very similar to the one that you're going to do in the practice situation. Okay, so let's take a look at this word problem. It says that we are looking at a horrible virus going around the world right now called the Q virus. It is spreading at an exponential rate. Let's take a look at this data. So even if you look January 1st, there were 2 cases. January 6th, 5 days went by, there are 50 cases already. That's exponential growth. It's happening so fast. Use this data to write an equation that models the exponential growth. Then, using that equation, answer a few questions to make predictions on the future number of cases. Okay, and that's super helpful. So how are we going to write an equation, right? What we're going to do is use something called exponential regression. Regression is a system that's going to calculate, using statistics, all of the information, the data that you provide them, and estimate where the equation is going to fit through the data. So you're going to use a website, and the website is linked to the practice, but this is what it looks like. And you can type in like just the X and Y for your day, right? The number of day, that's the X value, and the number of cases, that is the Y value. And I just went through and typed in the day. We just have information in the table, 0, 1, 2, 3, 4, 5. And then the number of cases, it was 2, 8, 10, 30, 39, and 50. And we can round to 3 decimal places. And if we hit calculate, notice it estimates, right? So it's going around and in between all of the points that are in our data. Because this is real life data, it's not exact, okay? But this equation estimates the average around those points to give me this equation. And this is the information that we want to pull out. So my equation equals y equals 3.028 times 1.872 to the x. Okay, and now I can go back and write that equation down. Let's just recall what this equation represents. So obviously x is day, y is the number of cases. 3.028, this first variable, if you go back to the beginning of exponential functions, I think that was 5.1, this first number represents the factor of change. So the amount that it's changing each time is roughly about 3.0828. The B term, this number right here, represents the initial value, the y-intercept. So you can see our y-intercept is actually 2, but like I said, the exponential regression estimates has to hit about all of these points from our data. So that's why it's a decimal and not exactly 2. Okay, so we're like this says, we're going to use this equation to now answer a few questions. So our first question says, next, use this equation to calculate the number of positive cases there will be in the future. So specifically, they want us to take a look at February 1st. On February 1st, how many cases of the Q virus will there be? So let's go ahead, and I have to figure out the day, right? So I can think about, okay, January, let's see, January 31st. There will be, that'll be the 30th day. Okay, so on January 31st, if I continue this and count all the way down, that'll be on day 30. So February 1st, my next day, that's the next one, right? February 1st, that'll be day 31. Okay, so that's why I can say when my X is 31, how many cases are there going to be? What's my Y value? Okay, so all we're going to do is take that information and put it right into the equation, right? 3.028 times 1.872 to the x value of 31, because that's going to represent February 1st. And then we're going to go ahead and put this into a calculator. I went and did, and if you don't have a calculator, you can use Desmos. It's perfect for this, desmos.com. I did this first, 1.872 to the 31st, and I got this huge number. And then I did this whole number times 3.028, that gives me roughly, oh boy, 836,829,627 people. I rounded to the nearest whole number with the Q virus. That's huge. In 31 days, almost like 800 million people. That's crazy. Okay, that's exponential growth. The next question we're going to answer is next, use the equation that we came up with in question number 1 to calculate how long. So now I'm looking at my days, right? There's my time. Now I want to figure out what's my X when 7.7 billion people have the virus. So that's everyone on Earth, okay? So I would write this on the side here. When my Y is 7.7 billion, that's about this number right here, what is my X? How long is that going to take? Okay, so I'm going to write that number into my equation, right? So now I have 7.7 billion equals 3.028 times 1.872, and I have that X because that's what I'm trying to find. So guys, use back to your 5.4 notes, solving exponential equations. That's all this is. First, I have to isolate my exponential term. Here is my exponential term I need to isolate. So I first need to divide both sides by 3.028, right? That's going to get that 1.872 to the X, that exponential term alone. When I divide 7.7 billion divided by 3.028, I get this number, some 2.5 billion number. How do I get this variable out of the exponent? Right, 5.4, we learned to take the ln of both sides, right? If I take the ln of both sides, I am going to be left with this, right? ln of 2.5 billion equals ln of 1.872. The whole point of us doing that, I'm going to zoom in a little bit more. Sorry. The whole point of us doing that was so now I can use the power property and take that variable and move it to the front, right? So now I have ln of this 2.5 billion equals X times ln of 1.872. I need to get this X alone, right? That's X times this ln. So how do I get that X alone? I divide by both sides by ln of 1.872. This is going to cancel, and I'll be left with X equals this whole number right here. You can type this right into a calculator, right into Desmos. ln, watch your parentheses, ln of 2.5 billion divided by ln of 1.872. And what we're going to get, now I can zoom out, what we're going to get is 34.5395. We can round, so about 35 days. In just 35 days, a little bit over a month, the entire world would have this Q virus that I made up. Okay, that's crazy. That's just showing you exponential growth. Okay, guys, so that is how we can use math to predict the future of infections. It's crazy. All right, guys, so you're going to go back through now the practice and try a similar problem. And this time, though, it is with the real world data of Delaware cases of the coronavirus. Pretty cool. Okay, good luck, guys. You got this.